welcome back to my channel. I am Upasana Taneja. In today's video, we are starting S3 group and we will see in detail what is S3 group. Okay, I know I have taught this topic earlier also. SN group, permutation group. What is permutation group? SN group. What is permutation and how do we make group? Because whenever we make a group, we need an operation. So in that video, which you can find on my channel in group theory playlist, you will find all details about this group. Okay, so here we are starting particularly S3 group. We will see order of elements of S3 group. So we will first of all we will make S3 group. How will we write? What is transposition? How do we find inverse? Okay, all these things, and finally we will see order of elements. Okay, so please watch this video till the very end, and I hope you will understand it. And if you get it, do tell me in comment section. I need your support, your motivation to make more and more videos. Okay, so let's start the topic now. What is S3 group? How can we write S3 group? It is a group of permutation. First of all, the name is group. Group means a set with some operation is satisfying four properties: closure, identity, associativity and inverse. These four properties. Okay, so what is S3 group? In every group we have an identity element. Okay, and we have, I can write it as this: 1 2 1 3 2 3 1 2 3 1 3 2. This is S3 group. And secondly, how can we write it? We can write it as this also. Identity element is 1 2 3. 1 is mapping in 1, 2 is mapping in 2, 3 is mapping in 3. This 1 2 cycle is 1 is mapping in 2, 2 in 1 and 3 in 3. If we have this element where 3 is mapping in 3, we don't need to write 3. We will just write it as 2 cycle, 1 3. Length of cycle is 2. Okay, 1 3. 1 is mapping in 3 and 3 is mapping in 1. Okay, 1 is mapping in 1, 2 is mapping in 3, 3 is mapping in 2. In this 2 3, this is 2 3. Okay, and next is 1 2 3. 1 is mapping in 2, 2 is mapping in 3, 3 is mapping in 1. And next is 1 3 2. So 1 is mapping in 3, 3 is mapping in 2 is mapping in 1 and 3 is mapping in 2. So these all elements we have in S3. And what is the operation of this group? Operation is composition of mappings. Composition of mapping. What is composition? How do we find? Suppose we want to see this group has identity. This group has closure property. If we will operate these two elements, what we will get? We will get an element from this group only. Okay, so that means this is closure property is verified. So how will we check it? We will check it. Suppose we are saying this is A element, this is B element, and we operate A star B. If we get an element C, where C belongs to this group only. Okay, A, B belongs to S3, and we operate A and B, and we get C, where C is from S3 only. That means closure property is verified. So how will we check that? And in this we will see how do we check composition of mappings. Suppose we have these two elements A and B, 1 2 3 2 3 1 and 1 2 3 3 2 1. So how will we find the product? So first of all we will check in this element. 1 is mapping to 3. We will write 1 2 3 here. Okay, so 1 is mapping to 3 and 3 is mapping to 1. So 1 is mapping to 1. Here 2 is mapping to 2, and now we will check these. 2 is mapping to 3. So 2 will map in 3. Here 3 is mapping in 1 and here 1 is mapping in 2. So 3 will map in 2. So this is 1 3 2. First of all we will see this. 1 is mapping in 3 and we will see image of 3 in this first one. So this is how we check compositions. Okay, so we got this 1 3 2. This is, that means this is C and C belongs to S3. This is how we check whether these all elements satisfy closure property. Okay. And similarly, we have identity. We will check inverse. What is inverse? Inverse is if we multiply this element 1, 2, 3, 2, 3, 1 with what element, that we get identity. This is called inverse. Okay. Because these are two cycles. So I will now explain. How will I explain? You know that if any element is self-invertible, if any element is self-invertible, that means order of that element is 2. Okay. So when we will check order of elements, then we will see how do we see these things. Okay. So now I told you that how do we check compositions. Okay. So now we will write our elements in this form only. This form. We will not discuss this in detail because you have seen this now. Now we will take this form only. Okay. So now come to this. So we have S3 like this. This is S3 now. Okay. And this is a group with respect to composition of mappings. So this is S3. Okay. You know 1, 2, 1, 3 and 2, 3. All these are two cycles. This is called cycle. Cycles means 1 is mapping to 2, 2 is mapping to 1. Okay, this means we will write is 1, 2. Because 3 was mapping in 3, so we will not write, we can write like this also. But how do we write this element? We will not write this element, we will write it as 1, 2 only. So these two cycles are called transpositions. Okay. And now what I was telling you inverse. How do we check inverse? See, we have this element 1, 2. What is the inverse of 1, 2? Inverse of 1, 2 is 2, 1. Okay. Now we have this element 1, 2, 3. What is the inverse of 1, 2, 3? It's 3, 2, 1. 3, 2, 1 means, okay. So first of all, see this. 1, 2 inverse is 2, 1. This means all these two cycles are self-invertible because 1, 2 inverse is 2, 1 and 2, 1 is equal to 1, 2. Okay, because 2 is mapping to 1, 1 is mapping to 2. So we can write it this is also. So this means these all elements are self-invertible. Okay. So all two cycles are self-invertible. Okay. Now we come to 1, 2, 3 inverse. This is 3, 2, 1. How can we write it? We can write it as 2, 1, 3. 2, 1, 3. 3 is mapping to 2. 3 is mapping to 2. 2 is mapping to 1. 2 is mapping to 1. 1 is mapping to 3. 1 is mapping to 3. So we can write it as 1, 3, 2. We can write it as this or this or this. These all are same. 3, 2, 1 is same as 2. 1, 3 is same as 1, 3, 2. So inverse of 1, 2, 3 is, inverse of this is this. Okay. Okay, so now we know how do we find inverse, what is transposition. We know, now we know all these things. Okay, so now we will see, is this a group? Yes, this is a group because this has closure property, this has identity. Similarly, it will have associativity, and this has inverse of all elements. These all are self-invertible. This is inverse of this, this is inverse of this. Okay, so that means if we will operate this element and this element, we will get identity. Identity is 1 is mapping to 1, 2 is mapping to 2, 3 is mapping to 3. We can write it as this. Okay. So 1, 2, 3. Now we know how can we operate this. First of all, we will write 1 here. 1 is mapping to 3. 3 is mapping to 1. So 1 will map to 1. Now 2 is mapping to 1. 1 is mapping to 2 is mapping to 1, 1 is mapping to 2. So 2 will map into 2 only. Okay. And 3 is mapping to 2 and 2 is mapping to 3. So 3 will map to 3 only. So when we will operate these two elements, we will get identity element. Okay. So this is identity element. This is how we see S3. And I hope now you have understood about S3. Okay, some small facts or some details about S3. Now we come to the topic, what is order of elements in S3? Okay, order of elements in S3. How many elements we have in S3? What is order of S3? Order of S3 is 6. Order of Sn is n factorial. Okay, we have discussed this in our video. Okay, please watch this video on my channel in group theory playlist. Okay, so order of elements, we have 6 elements in S3. Okay, order of group is 6. Now we need to find order of E, order of 1, 2, order of 2, 3, all these elements like this. Okay, so while discussing this, we will do some short tricks as well, which are very important for multiple choice questions. Okay, so now we come to order of S3 is 6. So whenever we talk about order, we have studied Lagrange theorem called what says that? That says order of element divides order of group. So order of element can be, order of elements can be, what can be the order of elements? 1, 2, 3 and 6. Can we have order of elements 6? No. Why? I have told you this reason many times. What is that reason? That whenever we know that S3 is a non-cyclic group. Okay. What is order of elements? That how many times we operate one element to get identity. This is called order. So how many times we can operate that element to get identity? So if I will operate one element 6 times, then it will generate a group of order 6. That means it will generate 6 S3. If it will generate S3, then S3 cannot be non-cyclic. Because what is cyclic group? If a group can be generated by one of its element, then that is a cyclic group. But if we will have an element of order 6, that means that element will generate S3. But no element can generate S3 because S3 is non-cyclic. So we cannot have element of order 6. We will have element of order 1, element of order 2 and element of order 3. Now we will check here what is, we know that we have only one element of order 1, that is identity. So now we will check elements of order 2 and elements of order 3. Now for checking elements of order 3, elements of order 2, first of all, now we know the concept that how many times I multiply this that I get identity. That will be the order of this element, and we know that the order of these element is 2. These are 2 cycles. Order of these elements is 2. Okay. And one short trick is, suppose you have a permutation like this 1, 2 and 3, or you have permutation like this 1, 2, 3. Okay. So what is the order of this permutation? Just see, this is 2 cycle, this is 1 cycle. Take LCM. Order is 2. Okay. This is 3 cycle. Take LCM. Order is 3. So how many cycles you have? Suppose this is 2, this is 2, this is 2, and take LCM, and whatever is the LCM, that will be the order of that permutation. Okay. So now we know that this is a 3 cycle. Okay. So this is order of this permutation is 3, this is 3, this is 2, 2, 2, 1. We know this. But suppose we have a big group, then how do we need to do? So we should have something to solve. Okay. Suppose we have S3. We are discussing about Sn group. Suppose we have n is equal to 3. Then we will see partitions of 3. What we will see? Partitions of 3. Whenever I teach you something, I want you to make your notes. so that if you will make your notes, you will memorize it easily. Okay, so you will know the things. If you will see once and you will then you will forget. Okay, so please write these things, make your notes properly, then you will memorize these things very easily. Okay, so for this n equal to 3, what do we need to do? We need to see the partitions. Partition of number is different, partition of a set is different. We are partitioning number 3 here. So what is partition? You can find one video on my channel. Please watch that video for partition knowledge. Okay, and if you have any doubt, do tell me in comment section. And if you are liking, please encourage me by telling how you are liking it and how did you get it. Okay, so this motivates me a lot. Share my videos if you can. I need your support. So now we come to partitions of 3. 3 can be partitioned like this. We can write 3. We can write 2 plus 1. We can write 1 plus 1 plus 1. Okay. So if we can partition it like this, these type of elements we will get. These type of elements mean 3 elements we have. So we can get 1, 2, 3 or 1, 3, 2. Others are same. 1, 2, 1, 3, 2, 3, 2. Others are same. We can get this element 1, 2, 3, 2, 1, 2, 1. Okay. Order will be 2. LCM is 2 here. Order is 2. LCM is 3 here. Order is 3. LCM is 1 here. Order is 1. So order of elements can be, we will see partitions, then we will see LCMs, and order of elements can be 1, 2, 3. Okay. And how do we find order of elements? Or we can say number of elements of order 3. Sorry. We will write it number of elements of order 3. Okay. Number of elements of order 2. We have 3 here. 3 raised to power 1 here. We can say that 3 raised to power 1 here. First of all, we will see n factorial. This is n is 3, n factorial. We will take 3. 3 raised to power 1 into 1 factorial. What was in power? Power is 1, so 1 factorial. So what is the solution? This is 2. So number of elements of order 3 is 2. Okay. Number of elements of order 2. 3 factorial, n factorial, order 2 we will get from here. So 2 raised to power 1 into 1 factorial. Multiply 1 raised to power is 1. 1 raised to power 1 into 1 factorial. So what we will get? We will get 3 here. Okay, when we will solve this, we will get 3. So number of elements of order 1. 3 factorial upon 1, 1, 1. 1 is 3 times. So 1 raised to power 3 into what is in power? 3. We will write 3 factorial. This is the formula. This is the short trick for calculating number of elements of order. Whatever is the order. Okay. This is the trick for that. So this will get 1. So we have 1 element of order 1, 3 elements of order 2 and 2 elements of order 3. And how do we find that? We have 3 elements of order, 2 elements of order 3. So this is 3, 1. Okay. 1, 2, 3 or 1, 3, 2. 2, 1. 1, 2, 3. 1, 3, 2. 2, 3, 1. 2, 1. 2, 1. Cycle of 2, 1. 2, 1. 2, 1. Okay. And this is 1, 1, 1. That means 1, 2, 3. So we got all the elements like this. Suppose we have a big group like S5, S6, then we don't need to write all the elements because S6 will have 6 factorial elements, 720 elements. So we don't need to write all the elements. Whatever we will get the question, we will get number of elements of order. I will take examples of that also. Number of elements of order 8. Okay, number of elements of order 10. First of all, we will see can we have a number of element of order 10? For that we will do partition of 6. So for this case I will discuss in another video. Okay, so I hope you understood this. So similarly, I told you this number of elements of order 3, number of elements of order 2, order 1. We can count it like this, and we had this partition. According to partition we can make elements. Okay, suppose we have these cycles. Now we know these are cycles. So there is another short tricks also. What is another short trick? If we have cycle of length 2, so number of cycles of length 2, we can find this also. So write that short trick now. So this is another short trick. Number of R cycles in Sn. This is also very simple. Suppose you know you have S6 or S3, whatever you have. So if you have 2 cycle, we know that this is 2 cycle. Okay. So number of 2 cycle in S3, we have R is 2, N is 3. So what is the formula? 3C2 into R is 2, 1 factorial. Okay, 3C2 is 3. So number of 2 cycle in S3 is 3. 1, 2, 3. Okay, so number of 3 cycle in S3, that means 3C3 into 2 factorial. Okay, NCR 3C3 into NR minus 1 means 3 minus 1 2 factorial. That is, we get 2 answer. So 3 cycle are 2, 1 and 2. So we can find in this way also. That depends on your question. Okay, just make your notes, do some practice with some bigger groups. Those bigger groups we will discuss in our new videos. Okay, upcoming videos. So I hope you got it. How do we find order of elements and everything like this? What is S3? How do we calculate and everything like this? If you have any doubt regarding S3, in next video we will discuss about subgroups of S3 also. Okay, we will see how do we make subgroups, how do we use theorems for making subgroups. Okay, so we will discuss that also. I hope till now you have understood about S3 and elements, order of its elements. Okay, so if you are getting it, do subscribe to my channel, please share my videos, and do tell me in comment section if you are liking, and please follow me on Telegram. It's channel Dr. Upasana Taneja. You can find all links in my channel description. Please visit my channel for real analysis, differential equation videos, and thank you so much for watching. Keep watching like this.